This is Foundations of Math and Pre-Calculus 10, Chapter 2.3, and we're going to be calculating volume. And as before, we're looking for how much stuff we can put into a container. And we're going to look at the volume of some new objects, and we're going to see that volume is easier to calculate than surface area. Let's look at the formulas from Chapter 1.1. So prism, length times width times height. Cube, length cubed, cylinder, pi r squared h. And we want to notice that we don't do any adding, it's all multiplying. And to derive the formulas for the volumes of spheres, right cones, and right pyramids, you need to use calculus. If you're really interested, you can approximate these formulas by slicing up the spheres and right cones into cylinders and adding them up. And we can look at this video to show us how we can get an estimate. So we can overestimate, and we can get an underestimate, which is inside the cone. This one's outside the cone. And to get a better estimate, you just average the two. I'll leave that as an exercise for yourself. So the formula for the volume of a sphere is 4/3 pi r cubed. The volume of a right cone is 1/3 pi r squared h. And for a right rectangular prism, we have 1/3 base 1 base 2 times height. Or you can choose to do 1/3 length, width, height. So let's go through some examples. Find the volume of a sphere in meters cubed and feet squared. So volume equals 4/3 pi r cubed. So this is 4/3 pi and 3 meters cubed. So we have 3 cubed, that's 27, but we divided by 3 here, so we get a 9. We take the 9, multiplied by 4, that's 36. So we have 36 pi. Again, it's always best to leave things as exact answers until the very end. You can plug this into the calculator, and we get 113.1 meters cubed. Now we need to do our conversion. 113.1 meters cubed times 1 foot over 0.3048 meters, and we cube the whole thing. We can cancel out the meters, and we get approximately 3994 feet cubed. Okay, let's go through these calculations. 36 pi and we get our 113.1 divided by 0.3048 cubed, and we get 3994. Let's look at the next one. Find the volume of a sphere in cubic inches and cubic centimeters. Again, start off with a formula. 4/3 pi r cubed, and we get 4/3 pi 6 inches cubed. We can plug this into the calculator. 6 cubed times 4 times pi divided by 3. You can change the order, and we get 904, rounded up to 905 inches cubed. 905 inches cubed times 2.54 centimeters over 1 inch and cubed. That means we can cancel out inches, and we get approximately times 2.54 cubed. Gives us a fairly large number, 14827 centimeters cubed. Now you might get a slightly different answer if you just use the rounded value, 9005 times 2.54 cubed. We get 14830 centimeters cubed. Okay, let's look at some more examples. The Great Pyramid in Egypt was the tallest building in the world for 3,800 years. It has a volume of 91,636,000 cubic feet. Its base is 756 feet by 756 feet. Determine the height in feet and meters. Okay, so this is a backwards problem. We'll start off with a formula. Volume equals 1/3, base 1, base 2, and height. 91,636,272 feet cubed equals 756 feet times 756 feet times h all over 3. And recall, if there's no operator between two numbers, it means we're multiplying it. So now we can solve for h. We solve for h by moving things across. So the 3 goes up to the top, and these two 756 move down to the bottom. And we're multiplying by 3. And 756 feet. And we're just going to square this so that we don't have to write so much out. And we'll get an approximate value. 3 times 91,636,272 divided by 756 squared. And we get 481 feet. So this is the height. We want to take this 481 and we are going to multiply it by 0.3048 meters and divide it by 1 foot. And we can cancel out the foot. And we don't cube it this time or square it this time because we're just dealing with a single length measurement. 481 times 0.3048, and we get 146.6 meters. And let's look at our last example. This is a composite object. A Nestle drumstick has a total volume of 148 cubic centimeters, or you could just say milliliters. Determine the height of the cone in centimeters. And it says we can assume that the scoop of ice cream at the top is a sphere. Okay, so it looks like a sphere. A little bit's going to overlap with the actual cone, but we're going to ignore that. Okay, I apologize. This should say diameter. And this should say diameter. It's not a very big cone. The volume of the scoop is 4/3 pi, and this is 5.4 centimeters, and this is 4.8 centimeters. So, since this is a diameter, we need to divide this by 2. 5.4 centimeters divided by 2 and cubed. So this is approximately 82 centimeters cubed. So let's punch that on the calculator to verify. We can do our 5.4 divided by 2, and we'll get the answer right away. And we'll cube it times 4 times pi divided by 3. And we get 82.4. We can round it off. Now, the volume of the cone is 148 cubic centimeters minus the scoop, which is 82 centimeters cubed. And that gives us 66 centimeters cubed. Now we take the 66 centimeters cubed, and we need the formula for a cone. So that's 1/3 pi r squared h. Substitute our values. Pi, the r is half the diameter, so 4.8 centimeters divided by 2 squared times h. And we divide the whole thing by 3. Okay, so this will go on the top. These two will go on the bottom. So we have 3 times 66 centimeters cubed equals h. And we're just going to draw a line here, just because I'm running out of space, over pi times 2.4 centimeters squared. Okay, so half of 4.8 is 2.4. Now we can just plug this in on a calculator, and h is approximately 3 times 66 divided by pi divided by 2.4 squared. And we get approximately 11 centimeters. And that's the height of the cone. And that completes this lesson.